In this video, I will explain how to divide a decimal by a number, how to divide by a power of 10, how to convert a decimal to a fraction, and also how to write repeating decimals in a shorthand manner. So starting with dividing a decimal by a number, here we have example 1 where we are told to divide 12.75 by 3. Now when you divide a decimal by a number, your division process will be the same as with regular numbers. So for example, we start with 12.75 and then we set up our division problem like this, and the 3 would go over here. So we begin the same way, where we see how many times does 3 go into 1. Well, it goes in 0 times. So we have to see how many times does 3 go into 12. 3 goes into 12 4 times. So we put a 4 here, and then we take 4 times 3 to get 12, put it down here. And then we subtract to get 0, and then bring down the 7 and repeat the process. Now the 4 is lined up with the 12, and the decimal point here needs to go right up above after the 4. So that's really the only thing different, is our decimal point needs to be in line with our final answer. So then we see how many times does 3 go into 7, and it goes 2 times. So we put a 2 here, and then multiply 2 times 3 to get 6, and then subtract to get 1, bring down the 5, and repeat the process. So 3 goes into 15 5 times, put a 5 up here, 5 times 3 is 15, subtract and we get 0, which means we have no remainder, and that means we are done with the division process. So our final answer would be 4.25. So again, notice the process is exactly the same as with regular numbers. The only thing different is with the decimal point, make sure our decimal point is lined up here and in our final answer up here. Here is another example. We have 14.5 divided by 5. This one is the same idea as example 1. So we do 14.5 and then put our divide symbol right there and then a 5 right here. And now we begin our division process. We see how many times does 5 go into 1, and it goes in 0 times. So now we need to see how many times does 5 go into 14. 5 goes into 14 2 times, and then we multiply 2 times 5 to get 10, subtract, and we get 4, bring down the 5, and repeat the process. And our decimal point needs to be right here after the 2. And now we repeat. 5 goes into 45 9 times, put a 9 here, multiply 9 times 5 to get 45, subtract, and our remainder is 0. So our final answer is 2.9. Example 3, we are still dealing with the same type of division, but now our divisor is a 2-digit number. So we're dividing by a 14 instead of a 1-digit number. So this again is the same process as with regular numbers. We would take 812.6 and then we set it up like this, and the 14 goes right there. So to begin, we want to see how many times does 14 go into 81, which would be 5 times. So put a 5 here and then multiply, and 5 times 14 would be 70. Now we subtract 81 minus 70, that gives us 11. Bring down the 2 and repeat the process. How many times does 14 go into 112? Now that one we can trial and error, but we're going to end up with an 8. Because 8 times 14, we get 32, carry the 3, 8 times 1 plus 3 is 11. That's exactly 112. Now we subtract and we get 0, and then we bring down the 6 and repeat the process. Now our decimal point would go right here after the 8, and then now the next number would go after that point. So now we ask ourselves, how many times does 14 go into and that is 0 times. So we put a 0 there. we do 0 times 14 to get 0. Subtract, we get 6. We need to add a 0 here at the end and then bring it down. So now we have 60 down here. And then we repeat. How many times does 14 go into 60? That's going to be 4 times. Let's put a 4 here, because 4 times 14 is 56. We subtract, and then we get 4. And then we still have a remainder, which means we have to add a 0, bring down, and then repeat again. And then we ask ourselves, how many times does 14 go into 40? And that's going to be, what, 2 times? 2 times 14 is 28. Subtract, and we get 12. So our answer, we were told in the instructions to round to the nearest hundredth. So the hundredth place is 2 digits after the decimal point. So the 0 is in the tenths place, the 4 is the hundredths place. So to round, we only need the thousandths place. We don't need to keep going. And because 2 is smaller than 5, that means the 4 remains here as a 4. So our solution is 58.04. Now switching gears, we're going to work with dividing by powers of 10. Dividing by powers of 10 is very quick. We can do this in our heads, because the process is we look at how many zeros we have after the 1 and the number of zeros after. That tells us how many places we move the decimal point. So the decimal point needs to move 1 place, because there's 1 0. It moves 1 place to the left, and it's going to be 4.539. We know the decimal point goes to the left and not the right, because we're dividing by 10, which means the number needs to be getting smaller than it was. So we started with 45, now we have 4.5. If we were multiplying by 10, the decimal point would go the other way to get 453.9. Now in dividing, we could also write 10 as 10 to the first power, which means we just have 1 10. So whatever the exponent is with the 10, that also tells us how many places to move the decimal point. So this is the same as the problem up here, because the exponent is 1, which means our decimal point is moving 1 place to the left. So again, we get 4.539. Now if you were told to divide by 100, notice we have 2 zeros, which means the decimal point moves over 2 places. And that gives us 0.4539. And 100 is the same thing as 10 squared, right? Because that would be 10 times 10, which is the same thing as 100. So again, here we see the exponent is 2, which also indicates to move the decimal point 2 places to the left. And that gives us 0.4539. We could keep going with any power of 10. So dividing by 1,000, there are 3 zeros, which means our decimal point moves over 3 places. So when you move it 3 places, we go 1, 2, and to move it over another place, we need to add a 0 in the front, and that now becomes 0.04539. And then 1,000 is the same thing as 10 to the third power, right? Because that is 10 times 10 times 10, which would equal 100 times 10, or 1,000. So we don't have to actually multiply it out, because this 3 here also tells us the number of zeros. And so again, we move the decimal point 3 places to the left, which would again give us a 0.04539. Now next, we're going to deal with converting fractions to decimals. And the process is the same as what we've been doing with dividing, because fractions mean division. So here when it says 3 over 8, this is another way of saying 3 divided by 8. So when you convert a fraction to a decimal, we can think division. So 3 over 8 is 3 divided by 8. So to divide, we set it up like this, 3 divided by 8. And here, 8 does not go into 3, which means we need to add a decimal point and then at least 1 0. And we begin by seeing how many times does 8 go into 30. So 8 goes into 30 3 times, and 3 goes right here above the 0 in the 30, and the decimal point needs to stay lined up. It's going to go right here. So now we do 3 times 8 to get 24. Subtract, we get 6. So because there's a remainder, we must add a 0, bring it down, and then repeat the process. 8 goes into 60 7 times. So then we do 7 times 8 to get 56. Subtract, and we get 4. So again, we have a remainder, which means we must add a 0, bring it down, and repeat the process. So 8 goes into 40 5 times. 5 times 8 is 40. Subtract, and we get 0. So now there's no remainder, which means our final answer is right here, which is the 0.375. Here is another example. We have 7 over 40. Now as a decimal, we can think of this as division, where we have 7 divided by 40. So we do 7 divided by 40. And we see how many times does 40 go into 7, which is 0. And if it's helpful, you can write the 0 in the front. You don't have to, but it might be helpful to line up the decimal point. And then so we have to add a decimal point and at least 1 0. Let's add maybe a couple. And then we see how many times does 40 go into 70. So 40 goes into 70 one time. Decimal point goes here. 1 times 40 is 40. Subtract, and we get 30. Bring down the 0 and repeat. How many times does 40 go into 300? That's going to be 7, because 7 times 40 is 280. We subtract, and we get 20. Let's put another 0 here, bring down. Now we have 200. And then we see how many times does 40 go into 200, which is 5 times. And then 5 times 40 is 200. Subtract, and we have no remainder. So our final answer is 0.175, or simply 0.175. Let's take a look at one more example like this. Here we see 9 over 20. Now this one, again, is division. So we have 9 divided by 20. And then when we set up, we can put a 9, let's do it right here. Let's put a 9 here, and divide by 20. Now 20 goes into 9 0 times, so we have to add a decimal point and then some zeros after. And then we ask ourselves, how many times does 20 go into 90? Well, that is 4 times. And then 4 times 20 is 80. Subtract, we get 10. Bring down the 0 and repeat. 20 goes into 100 5 times. Put a 5 here. 5 times 20 is 100. Subtract, and we get 0. So we have no remainder remaining, which means our final answer is 0.45, or simply 0.45. Now, sometimes when you convert from a fraction to a decimal, we have what is called repeating decimals. So for example, if we had 4 divided by 9, so if we begin this division process, we'd have to add a decimal point and a 0. 9 goes into 40 4 times. Decimal point goes right here. 4 times 9 is 36. Subtract, and we get 4. And then let's add a 0 here, bring it down, and repeat. Notice again we have a 40. 9 goes into 40 again 4 times. 4 times 9 is 36. Subtract, we get 4. Put a 0, bring it down, and repeat. And we have a 40 again, a third time. So this is going to keep going on forever. We're going to keep getting a 4 and a 4 and a 4. So the 4s are repeating. Okay, that's what we call a repeating decimal. The number 4 is repeating over and over again. Now, if we're not told to round, and we're told to write as exact as possible, another way of writing this is we can put a bar over top of the number that is repeating. So the 4 is repeating, so I put a bar over top of it like this, and that signifies that the 4 will keep going forever and ever and ever. All right, so make sure you know how to write a repeating decimal with the bar on the top. Okay, let's look at another example like this. So we have 5 divided by 6. When you divide these together, we have to add a decimal point and a 0. 6 goes into 50 5 times. Decimal point goes here. 8 times 6 is 48. Subtract and we get 2. Add a 0 at the end. Bring it down and repeat. 6 goes into 20 3 times. 3 times 6 is 18. Subtract, we get 2. Let's put a 0 here. Bring it down and repeat. So again, we have 20, just like we did right here, which means the number we just had is going to keep going on forever and ever. So we're going to get a 3 again. 3 times 6 is 18. Subtract, we get 2. Notice the 3 is going to keep repeating. All right, so in this case, it's just the 3 that is repeating. The 3 is going on forever. So the only number with the bar on top would just be the 3. So the way you write this is 0.8 and then 3 with the bar over top of the 3. So it's not over the 8 also because the 8 is not repeating. It's just the 3. However, there are times, like right here, when you have 7 divided by 11, when it will be more than one number repeating. So this one, when you divide 7 by 11, we put a decimal point and a 0 here. 11 goes into 76 times. 6 times 11 is 66. Subtract and we get 4. We put a 0 here, bring it down and repeat. 11 goes into 40 3 times. 3 times 11 is 33. Subtract and we get 7. We have to add a 0, bring it down and repeat. Notice we have exactly what we started with. We started with 70, and that's how we got the 6, right? So we can keep going if you wanted, if you don't see that right away. But 11 goes into 76 times. 6 times 11 is 66. Subtract, we get 4. Add a 0, bring it down. And now we have 40, which is exactly what we had right here. And that gave us a 3. So 3 times 11 is 33. Subtract, we get 7. It's going to keep going forever like that. So what we have is 0.636363, etc. goes on forever. And so when we write this with the repeating bar, the bar goes over the 6 and the 3 because both 6 and 3 are repeating. All right, so the bar goes over the repeating numbers only. In the other example, the 8 was not repeating, so it did not go over the 8. Here, the 6 and the 3 are both repeating, so the bar goes over both numbers. And that concludes our lesson for today. We will see you next time.